Hey everyone, welcome back to Sir Math's channel, where math isn't just numbers, it's an adventure. Today, we're diving into the derivatives of exponential and logarithmic functions. These are essential when solving real-life problems involving growth, decay, and more. Let's get started. Let's start with one of the most powerful functions in calculus, the natural exponential function, or we have e to the power of u. This is unique. The derivative of e to the power of u is just e to the power of u. Times, we have of course the derivative of our exponent here with respect to x. It stays the same, no changes. Let's have an example. Differentiate y equals e to the power of 3x squared plus 2x minus 1. So, getting the derivative, since it's the same, it stayed the same. So, just write the given, e to the power of 3x squared plus 2x minus 1. So, of course, we don't forget to multiply whatever is the function, the exponent, or the function in the exponent. So, we have the derivative of 3x squared, which is just 3 times 2 times x to the power of 2 minus 1, plus the derivative of 2x, which is just 2 times 1, minus the derivative of 1, constant, so that's why it is 0. Simplifying this further will give us e to the power of 3x squared plus 2x minus 1 times the quantity of 6x plus 2. And then, of course, we just rearrange. So we have the quantity of 6x plus 2 times e to the power of 3x squared plus 2x minus 1. So this is the answer. Now, what if we're working with a different base like 2 or 10, not e? The rule becomes slightly different. So we have now the formula for the derivative of exponential function a to the power of u, where a can be any constant. So we have the derivative here of a to the power of u. So it's just almost similar to e to the power of u. So we write a to the power of u, but there is already here the natural log of the base a. So times, of course, the derivative of u with respect to x. Let's have an example. Differentiate y equals 3 to the power of 4x plus 5. So we write the given 3 to the power of 4x plus 5, but again, there is the natural log of the base. Our base here is 3, so we have ln of 3 here, the natural log of 3. Times, of course, the derivative of the exponent, 4x plus 5, so we have the derivative of 4x is 4 times 1, plus the derivative of 5, which is 0. So if we simplify this further, so 4 times 1 plus 0 is just 4, and then rearrange. So again, do not multiply 4 to 3, because again 3 here is an input value of the natural logarithm. So we just rearrange. So we now have 4 times ln of 3 times 3 to the power of 4x plus 5. And this will be the final answer. Now on to logarithmic functions. Let's start with the natural log, or ln of u. So the derivative of ln of u with respect to x is just 1 over u times the derivative of u with respect to x. Let's have an example. Differentiate y equals ln of 4x cubed plus 3. So take note, our u is 4x cubed plus 3. So we just have 1 over 4x cubed plus 3. So because it's 1 over u, just copy whatever is inside the parenthesis here, or the input value, in the denominator. And then, of course, don't forget to multiply the derivative of u. So again, our u is 4x cubed plus 3. So the derivative of 4x cubed is just 4 times 3, x to the power of 3 minus 1, plus the derivative of 3 is 0. So simplifying this, so we have 4 times 3, which is 12. Then, of course, x to the power of 3 minus 1 is 2, x squared. And of course, disregard 0. Then multiply it to the numerator here so that we can simplify further. So we will get 12x squared all over 4x cubed plus 3. And this is already the final answer. Lastly, for logs with any base a, constant a, so we will have here the derivative of the logarithmic function log to the base a of u. So the formula is just very similar to natural log of u. We still have 1 over u, but now we have the natural log of a in the denominator. So 1 over u ln of a times the derivative of u with respect to x. Let's have an example. So differentiate y equals log to the base 2 of 5x cubed. So again, it's just 1 over u. Our u here is 5x cubed. So that's why we have 1 over 5x cubed. But take note, there is ln of a. So our a here is 2. That's why we have ln of 2 here. And then times the derivative of u. So derivative of 5x cubed is just 5 times 3x to the power of 3 minus 1 plus 0. So simplifying this further, so 5 times 3 is 15. X to the power of 3 minus 1 is x squared all over 5x cubed ln of 2. Note that we can still simplify this further. So we can cancel out 15 and 5. So there will be 3 in the numerator. And of course, x squared and x cubed, there will be x in the denominator. So we have 3 over 5x ln of 2. And this will be the final answer. Let's quickly recap everything we've learned today. So we have the derivatives of exponential and logarithmic functions. There are only 4. Derivative of e to the power of u is just e to the power of u times the derivative of u with respect to x. Derivative of a to the power of u, where a can be any constant, is just a to the power of u times the natural log of a times the derivative of u with respect to x. Then for logarithms, we have the derivative of the natural log of u is just 1 over u times the derivative of u with respect to x. And lastly, we have the derivative of log to the base a of u is just 1 over u times the natural log of a times the derivative of u with respect to x. These rules will help you take on more complex derivatives using chain rule, product rule, and beyond. And again, they are very important because these functions are related to growth, decay, and many more. That wraps up our tutorial on derivatives of exponential and logarithmic functions. I hope this helped solidify these important concepts. If this video helped, give it a like, subscribe for more math tutorials, and hit the bell so you never missed out. Got questions or suggestions? Drop them in the comment below. I'd love to hear from you. Keep calculating and stay curious. See you next time. Bye-bye.